warm welcome to anyone joining to Earth Educational Channel. I wish you good evening, good morning and good afternoon. So in the previous lecture we have started the third chapter of NCERT in mathematics, that is coordinate geometry. Okay, so in the coordinate geometry had three sections actually. First section was introduction, second section is Cartesian systems that we'll be looking today, and the third section is plotting a point in the plane if the coordinates are given. And the last section we saw the introductory part of coordinate geometry. We saw some real life examples and we looked into what is plane actually. Okay, so discuss real life examples and how coordinate geometry affects in real life. Okay, so today we will be discussing about Cartesian system. What is Cartesian system? We will first look into the number line. Okay, and then from there on we will move into Cartesian system. Okay, and what does Cartesian system inculcate? So let's start with the video. First, in the number system chapter, I talked about the number line. In number line, what was in the number line? In number line chapter, in the number system chapter, I talked about number line, in which number line consisted of a line. We fixed a number. We fixed that number, that is the zeroth number we fixed. Okay, that we called it as the origin. Our fixed number was what? The origin. And to the right of the origin, we wrote all the positive numbers, that is 1, then 2, then 3, then 4 and so on till infinity. And to the left of the origin, that is the fixed number, all the negative numbers were there till minus infinity. Okay, so at first in the number line we fixed an origin, we had a fixed number, and in reference to that fixed number at equal distances we drew other numbers. Okay, at equal distances we drew other numbers. See, the distance between 0 to 1 is same as the distance between 1 to 2, is same as the distance between 1 to 3. So the distance between 0 to 1 is suppose 1 unit. 0 to 1 is 1 unit. Okay, so 0 to 3, how many units it will be? It will be 3 units. Why? See, 0 to 1 is 1 unit, 1 to 2, 1 more unit, then 2 to 3 is 1 more unit. So 1 plus 1 plus 1 equals to what? 3 units is the distance. So to find the location of the number 3, what we did? We took 0 to 1 as suppose 1 unit. It can be 1 centimeter, 1 meter, whatever. Okay, 1 unit distance. So to find the location of number 3 in the number line, we took the distance as 3 units. The distance, the point at 3 units distance will give the number 3, and that too on which side? On the right side. Number 3 will lie on the right side of the number of the fixed number, and minus 3 will lie on the left side. Okay, so these things we had discussed. So here the same thing is written as, in number line a single point is plotted from a fixed point where distances from fixed point is marked in equal units. I already said this is a fixed point. Okay, to plot another number see, we first fix the point, then to plot the another number in reference to that fixed point we find the distance. So it is written, in number line a single point is plotted from a fixed point where distances from fixed point is marked in equal units in both directions of the fixed number. All in both the directions, left side and right side, equal distances are marked. In one direction the numbers are positively marked, that is the right side, and the other direction it is negatively marked, that is the left side. Okay, so this whole sentence, that is clear. So in number line represents numbers by marking points at equal distances on the line. See, all the numbers can be represented in number line. This is 0, then the positive numbers are 1, 2, 3, 4 and so on till infinity it goes. Similarly, this is minus 1, this is minus 2, this is minus 3 and so on till minus infinity it will go. So number line, what does it do? It represents numbers by marking points at equal distances on the line. Got my point? Then the fixed point is generally the origin, which represents the number 0. I have already told you, generally the fixed point is what? Generally it is 0. In reference to 0, we can draw a number line starting with 1 also. Okay, we can draw a number line starting with 1 also. We can keep 1 as the reference number. That is possible. But generally, to showcase the negative and the positive portions, 0 is the fixed number or the origin. Why? See, 0 lies between the middle of the all the negative numbers and the positive numbers. It lies in between. So generally, it is better to showcase the means you keep the origin as 0. Got my point? Then the third point, it is written as the number 1 is represented as a unit distance from the origin. Similarly, number 3 is represented as 3 units from the origin. Whatever be the distance between 0 to 1 or 0 to -1, okay, that is 1 unit of distance. That is 1 unit of distance for the number line. That is 1 unit of distance for the number line. Okay, whatever be the distance, let it be 1 centimeter or 1 meter or 1 kilometer even 1 kilometer, whatever be the distance from 0 to 1, that is 1 unit. So anything further than 1, that will be what? Multiple of that distance. That will be multiple of that distance. Got my point? Suppose 0 to 3 is 3 into distance. Okay, that distance is what? It's distance between 0 to 1. Because in number line, the distance between two numbers is always equal. Okay, so that thing. Fourth point written is numbers to the right of the origin are positive numbers represented by R. I already told you. See, this is a number line. Our fixed point is 0. All the numbers to the right, that is, are positive numbers. Okay, that are positive numbers. Positive numbers. See, positive I will be writing as this, to as a shortcut form I will be writing plus V. Okay, negative will be minus V. This is to save time also. Okay, this is a convention that that is followed. Okay, plus V and minus V you can write. So to the right side of the number line from the origin, okay, there are positive numbers that is represented by the number R, and to the left side of the origin there are negative numbers represented by what? Represented by minus R. All the numbers, that is 1, 2, 3. Okay, there is -1, -2, -3. All the positive and all the negative numbers are present in the number line. So this is the reference. This is in number line we can find what? A single number. We could find only a what? A single number we could find. Because why? Because number line is one dimensional. Number line is what? Number line is one dimensional. Okay, one dimensional. So only one data or information is required. Only one data or information, okay, is required to plot the number on the line. Okay, since one dimensional, in the last class also I said one dimensional is what? One dimensional means only in one direction. This is one direction, that is west to east, or from east to west, that is also one directional. This is north to south. Only in one direction only you can move. Got my point? In one dimensional, only in either or, only in one direction you can move. You cannot move in two directions simultaneously. Okay, but in two dimensional you can move in two directions simultaneously. That is two dimensional. Number line is a one dimensional story. Number line is what? Number line is a one dimensional story. So to plot a number on a number line, we need only one data, that is the distance from origin. To find a number from the number line, you need the distance from the origin for that number. Got my point? But we will see in 2D that is not the case. Why? In the last class also we saw that in the first example, your friend said that he is on 6th street. That is one information that you had, that is 6th street. Okay, so you went to 6th street, but you couldn't find his house. So what did you do? You called him again, and then he said that in 6th street the second home is his house. So you required two pieces of information. That is the first, the street number, then the house number. That is why, because that was a 2D problem. That this number line is a 1D problem, one dimensional problem. Cartesian system, that is actually a 2D, two dimensional problem that requires two datas or two information. You can say it requires two information to locate a point, because each point will be referenced using two numbers. Okay, each point will be referenced using two numbers. Got my point? So we'll discuss about that in the next slide now, that is Cartesian system. What is Cartesian system actually? Okay, see, it is written here, when two such number lines are placed perpendicular to each other on a plane, it forms the Cartesian system. See, I have taken one number line. This is the number line that we usually draw. Okay, that is the horizontal number line. This is the horizontal number line. If one number line has to be perpendicular to the other, if one number line has to be perpendicular to the other, it is 90 degree. So it has to be rotated by 90 degrees or not. If I rotate this by 90 degrees, I will get this number line. Okay, if I rotate this number line by 90 degrees, I will get this number line. Okay, so it is saying that two such number lines are placed perpendicular to each other. Okay, so place these two number lines. This is the horizontal x dash. If I place those two in a perpendicular, if I rotate it by 90 degrees, that is y dash. This is 90 degree. If I place those two are perpendicular to each other, okay, it forms the Cartesian system. It is saying that we can use this system to locate position of points on a 2D surface. Last class I discussed what is 2D surface. What is 2D surface? 2D surface is those that you can feel the top or the bottom. Top or the bottom. There is no side part. No side part. Okay, there is no height. Only two surfaces are there. That is top or bottom. Okay, there is no side part. Got my point? So in 2D surface, those are two-dimensional surfaces. So in two-dimensional surfaces, to locate the position of a point, see, this is the position of a point. If I draw a Cartesian system and I say this is the, what is the position of this point here? You have to find. So the use of this Cartesian system is to locate the position of a point on a 2D surface. Got my point? And it is saying that the perpendicular lines could be in any direction. In the last class also I said that see, here I drew a horizontal line and a vertical line. But in the last class also I said that it need not be necessary that this is a vertical line and this is a horizontal and vertical line. It can be an inclined also. But both the lines should be perpendicular to each other. Okay. The lines can be inclined to each other, means the lines can be inclined also, but they should be perpendicular to each other. And the location of a point in such a condition, that is when the axes are inclined. Okay, when the axes are inclined, it will be taught in 11th class. Okay, this is not the portion of 9th class or 10th class. Okay, so to find the perpendicular, so the axes can be inclined, but for simplicity purpose and for 10th and 9th class coordinate geometry, we will be using only the horizontal number line and the vertical number line in Cartesian system. Okay, in Cartesian system we will only using horizontal and vertical number lines. Okay, so what it is saying, to form a Cartesian system, what do we have to do? The first step is take a horizontal number line with 0 as the origin. This is the horizontal number line. 0 acts as the origin. Positive numbers to the right and negative numbers to the left. Same thing, positive numbers to the right, negative numbers to the left, and we are naming it as x dash x. Okay, we are naming it as x dash x. Okay, then it is saying take a vertical number line with origin at 0 and positive numbers to the top and negative numbers to the bottom. Again we are taking a number line, but this time it is a vertical number line. We have not discussed a vertical number line. Again we are taking number as 0. Top numbers are positive. See here, positive numbers 1, 2, 3, 4. And at the bottom of the origin, the negative numbers -1, -2, -3. All the negative numbers are existing. So this is a vertical number line. This is a positive number line. We have to take this positive horizontal number line is what? We are calling it x dash x, and the vertical number line we are calling it as y dash y. We have to take this, we have to draw these two number lines. Okay, we will moving on to the next step now. What is the next step? Next step, it is saying combine both the number lines such that their origins coincide. What is their origins? Their origins are this 0 point. Okay, you combine, you take this line to here, so their origins will coincide. There will be 0 here. This is 1, 2, 3, -1, -2, -3. Got my point? So combine both the number lines x dash x and y dash y such that their origins coincide. So this, after combining it, this will look like this. The two number lines will look like this. This is the horizontal number line x dash x. This is the vertical number line y dash y. Okay, we are combining it at the origin of both the points. Origin of x dash was 0 and origin of y dash y was also 0. So we are combining their 0 points together. So this forms what? This forms the Cartesian system. Okay, and it is saying that, sorry, the intersection point of both the number lines is called the origin, denoted by O. This is the intersection point of both the origin, both the number lines. This is the intersection point of both the number lines, that is 0th point, and it is denoted by what? The origin is denoted by O. This is what? This is called the origin. This is called the origin. The third point it is written here. The horizontal number line is what? X dash is called the x-axis. The vertical number line y dash is called the y-axis. Okay. This is the horizontal line is called x-axis. Vertical one is called y-axis. That is written here. Only terminologies are there. Say origin, you got it. The intersection point of both the number lines is the origin. Okay, the horizontal number line is called the x-axis. The vertical number line is called what? The y-axis. Okay, now OX and OY are called positive directions. Why they are called positive directions? See, this is OX, this is O, this is X. OX, in OX direction only positive numbers 1, 2, 3, 4, only positive numbers are there. Similarly, in OY directions, only positive numbers. There's 1, 2, 3, 4. Only positive numbers are there in OX and OY directions. That is why OX and OY are called what? Positive directions. Since positive numbers are lie in this direction. Similarly, OX dash and OY dash are called negative directions. Why? Since negative numbers are only present in this direction. This is OX dash. Okay, only negative numbers -1, -2, -3, -4. Same thing with OY dash. This is -1, -2, -3, -4. Both are negative. In both the directions OX dash and OY dash, only negative numbers are there. That is why they are called negative directions. And in OX and OY dash, these are called positive directions. Okay, so here we have talked about origin, y-axis, x-axis, and positive and negative directions. Got my point? These are the terminologies. Second part is in number line. In number line, used to divide. In number line, used to divide the number A, the origin used to divide the number line into two parts. This is the positive part. This is the positive part. This is the negative part. Number line was divided into what? Two parts. But here the two number lines divide the plane into what? Divide the plane into four parts. Four parts, and those parts are what called? Those parts are called quadrants. Quad means four, so these are called quadrants. What my point? These are called quadrants. Okay, these are called quadrants, and the whole plane. This whole plane. Last class I talked about plane. What is plane? Plane is a 2D flat surface. 2D flat surface is called a plane. That will extend infinity in all directions. Okay, it will extend to infinity in all directions. What is plane? Plane is a 2D surface that is flat and extends to infinity in all directions. That thing we discussed in previous video, in the first introductory video. So this whole thing is what? This is a plane. And what do we call this plane? We call this plane as what? We call this plane as Cartesian plane. Cartesian plane or coordinate plane also we call it. Or we call it XY plane also. XY plane. Okay. Cartesian plane, coordinate plane or XY plane. Since this is made up of what? X axis and Y axis, this is called XY plane. We call it as Cartesian plane based on the scientist, based on the mathematician, not scientist, mathematician who gave the concept of this, Demarcus. Okay, and or we call it as coordinate system also, coordinate plane also. Okay, so let me come into this quadrant part. See, the first, this always, this OX and OY part will be the first quadrant, always. This positive part and this negative portion will always be called as the first quadrant. Okay, this is always the first quadrant, and from there we rotate clockwise to get the other quadrants, anti-clockwise, sorry. We rotate anti-clockwise now to get the second quadrant. This is quadrant 2. Okay, then again this is quadrant 3. quadrant 3, and again this is quadrant 4. What my point? So this quadrant, that is consisting of all the positive numbers only. Okay, in the x-axis positive numbers, y-axis positive, that is called the first quadrant. Okay, then we will rotate anti-clockwise to get all the other quadrants. This is first quadrant, then the second one will be anti-clockwise part. We will rotate anti-clockwise to get the second, then again third, then fourth. Okay, so these are the what? These are the 4 quadrants: first quadrant, second, third, and 4 quadrants of a what? Coordinate Cartesian plane, coordinate plane, or xy plane, you can say. Now it is saying that the axes are called coordinate axes. The axes are called coordinate axes. So this is one axis, this is one x-axis. So it is a coordinate axis. This is y-axis, so this is also a coordinate axis. Okay. So these are terminologies. Why we are learning the terminologies? Because if somewhere coordinate axis is mentioned, you should know that it is referring to x-axis or y-axis it is referring to. If somewhere it is mentioned a Cartesian plane instead of xy plane, it is mentioned Cartesian plane, you should know that it is referring to xy plane only. Okay, you should know about these 4 quadrants. We'll look into it, the properties of these 4 quadrants. Okay, we look into the properties of these 4 quadrants in the last slide. Oh, but you remember that this the quadrant where the x-axis only contains the positive numbers, y-axis contains the negative numbers, that is the first quadrant, and there from there on we will rotate anti-clockwise to get the second, then third, then fourth quadrants. Got my point? So let us what? Take some minutes and recap what all we have learned. The first thing we have learned about is the number line. Okay. Sorry. In number line, we saw that we drew a line. Okay. We fixed the origin, that is the 0th number. On the right hand side there is the positive. On the right hand side there is the positive numbers. On the left hand side there is the negative numbers. Number line is what? Number line is a one-dimensional thing. Number line is a one-dimensional object. Okay, because it only moves in one direction. One-dimensional means only one direction is available to you. Okay, so if one-dimensional means we know we need only one data or information to plot the number on the number line. What is the data? That is data is the distance from the origin. Distance from the origin is the data required to plot that number. Okay, if I want to plot number 3, I need to what? I need to plot 3 times, means 3 unit of distance. 3 unit distance I have to travel to get the number 3 from the origin. I have to travel 3 unit distance from the fixed number to get the number 3. Got my point? So that thing we have talked about in number system. And number system was used to locate the location of a point on the number line. Then we moved on to 2D systems. To locate the number, to locate a number, to locate the position of a number in a 2D system, that is 2-dimensional system. 2-dimensional means we can move in 2 directions at a time. That is east to west, north south. Okay, 2 directions. To locate the position of a number in a 2D system, position of a point on a 2D system, we use the Cartesian system. And Cartesian system is made up of what? Cartesian system is made up of 2 number lines placed perpendicular. This is the horizontal number line, this is the vertical. When we place these 2 number lines perpendicular to each other, then we get what? We get the Cartesian system, and we use it to locate position of points on a 2D system. Okay, and they can be inclined. The 2 axes can be inclined, but for simplicity purpose, we are taking one axis as horizontal, the other axis as vertical. Okay, so we are taking one axis, the horizontal axis, as x dash axis, the vertical axis as y dash axis. We are naming. We are taking 2 axes. We are combining the axis at the origins of both the axes, at the fixed number of both the axes, that is the 0th point. That is called the origin. The x dash x axis is called the x axis. Is called the x axis. Okay, the y dash axis is called the y axis, and OX and OY are called the positive directions, and OX dash OY dash are called the negative directions. Why? Because in OX and OY directions only positive numbers are present. In OX dash and OY directions only negative numbers are present. Okay, this Cartesian system convert these two axes, divide the whole plane into 4 quadrants. This is the first quadrant. First quadrant is always in the those quadrant in x-axis is positive, contains positive numbers, y-axis contains also positive numbers. When both x-axis and y-axis contains positive numbers, that is the first quadrant. Then we rotate anti-clockwise to get the second, third and fourth quadrant. So we have 4 quadrants. Okay, this whole plane is called what? This plane is called Cartesian coordinate or xy plane. We can call Cartesian plane, coordinate plane or xy plane we can call. And these axes, that is x-axis and y-axis, are called what? They are called coordinate axis. Okay, so these all things we have learned. Now we will moving on to, the ultimate aim was to find the position of a point. The ultimate aim of coordinate system was to find the position of a point on the Cartesian plane. That was our ultimate aim. So we'll now look into how to find the position of a point on the Cartesian plane. Okay, so we are given 2 points, P and Q we are given. We have to find the position of P and Q in this Cartesian plane. Okay, so what we have to do for that? What is the procedure? The procedure is, first point it is written, to find the location of points P and Q, we need to find the distance of the points from both the axes. See, in the last video, in the introductory part, one example was to find the location of this dot in this piece of paper. We have to find the location of this dot on the piece of paper. So Rahul was intelligent. What did he do? He found the distance of this piece of paper, of this dot on the piece of paper, from the left edge and the bottom edge. This is the left edge. This is the left edge. This is the bottom edge. Got my point? So what did he do? This is the piece of paper. So he found the distance from the left edge and he found the distance from the bottom edge. Okay. So he was saying that the position of this point is what? The position of this point is 3 cm from the left edge and 9 cm from the bottom edge. This thing we looked at the previous class. Okay. The same thing is happening here, but in a piece of paper, there was left edge, there was bottom edge, there was top edge, there was right edge. So you could have calculated the distance from right edge also and top edge also of this point. Okay, there are 4 ways of mentioning the position of this point. But if you suppose see here, P is lying in the first quadrant. P is lying in the first quadrant. Okay, P is lying in the first quadrant. Here you can see there is no top edge, there is no right edge. There is only what? Left edge and bottom edge. The y-axis acts as the left edge, the x-axis acts as the bottom edge. Okay, we have to find the distance from these edges to define the position of that point. So the same thing we will do. What was Rahul doing? He was taking a scale and measuring the distance from the left edge to the point. Okay, he was taking the scale, he was measuring the distance from the bottom edge to the point. So ultimately what he was doing? He was drawing a perpendicular, an imaginary perpendicular line from the bottom edge to the point, and from the left edge to the point. He was drawing a imaginary perpendicular line using the scale. So the same thing we will do here. We will draw 2 perpendicular lines. This is the perpendicular line. This is the perpendicular line. We are drawing 2 perpendicular lines. To whom? To y-axis and to x-axis. We will draw the perpendicular. To y-axis 1 perpendicular line, to x-axis 1 perpendicular line. Okay. So it is written here, to find the distance of point P from x-axis and y-axis, we draw perpendicular from the points to both the axes, that is PM and PN. Okay. So PM is one perpendicular, PM is the perpendicular to the x-axis, PN is the perpendicular to the y-axis. Why did we draw the perpendiculars? To find the distance of the point P from the y-axis, and from the x-axis we draw these perpendiculars. Similarly, same thing will happen with what? Same thing will happen with point Q. We will draw these 2 perpendiculars. To x-axis and to y-axis we will draw the perpendiculars. To find what? To find the distance of this point from the x-axis and from the y-axis. Okay. How can we find the distance? See, these are number lines. So every distance between 2 points are equal. Distance between 2 points are equal. Since this is a number line, these two are number lines. So distance between 2 points are equal. So distances means how much distance you are covering from the origin, that is the distance, or not. How much distance you are covering from the origin, that is the distance. So if I say that, so we draw the perpendiculars. Okay, this is the procedure. So to find the distance, what we are going to do? From the origin we will go to that point. Okay, from the origin. So see, this origin and this origin are on the same line. This origin and this point N are on the same line. So you can start calculating the distance from N point also. So this N to 1, this is 1 unit, then 1 to 2 is 1 unit, this is another 1 unit, this is another 1 unit. So this is 1 1 1 1. So 4 times 1 is 4 into 1 is what? 4 units. So the distance between N to Pn is what? The distance of Pn is, the length of Pn we can say is 4 units. How 4 units again? 1 2 3 4. Got my point? Similarly, the distance from P to x-axis, this is y-axis. From P to x-axis is what? This is from x-axis, this is 1 unit, 2 unit, 3 unit. So distance it is coming as what? Distance is coming as 3 units. So it is written here, the perpendicular distance of point P from y-axis measured along the positive x-axis. Okay, why it is written that measured along positive direction of x-axis? Why it is written? Why it is written as measured along the positive direction of x-axis? Because we require this direction of x-axis, either whether it is positive or negative direction of x-axis, we require this to find the coordinates actually. Why it is required? See, the distance of this point P from y-axis is calculated along the positive direction of x-axis. Okay, along the positive direction of x-axis. This is the positive direction of x-axis. This is the negative direction of x-axis. So it is calculated along the positive direction of x-axis. And the distance is coming as 4 units. Okay. Similarly, the perpendicular distance of point P I calculated, that is coming as along the y-axis. It is calculated from the distance of point P from x-axis calculated along the positive direction of y-axis. That is coming as 3 units. Okay. Similarly, for point Q also we will do. For point Q, distance from the y-axis along negative direction. Here the direction is negative direction of x-axis. Okay, from y-axis the distance is coming of point Q. What is coming? This is 1 2 3 units. So the distance is 3 units from y-axis. Similarly, from x-axis, how much is the distance? This is 1 unit, this is 2 units. So the distance from x-axis is along the negative direction of y-axis. Here the direction of y-axis is negative. Along the negative direction you are calculating the distance. So the distance along the negative direction of y-axis from x-axis of point Q is what? Coming as 2 units. So distance you got this 4 units, 3 units, 2 units and 3 units. Okay, these are the distances part. Got my point? You got the distance. To calculate the coordinates, I was telling that you require along which direction of x-axis or y-axis you are calculating. Why? See, it is written here, a number, suppose this is point P, it is defined using 2 numbers. That is what? X coordinate and y coordinate. Got my point? A number P is defined using what? X coordinate, let me write it properly. X coordinate and y coordinate. Okay, x coordinate and y coordinate. X coordinate is called abscissa. And y coordinate is called ordinate. Okay, x coordinate is called abscissa, y coordinate is called ordinate. Now what is x coordinate? X coordinate is actually the distance of the point from the y axis. Okay, the opposite. The distance of the point from the y axis is the x coordinate. Why? See, x coordinate means what is the number you reached at that point on the x axis. That is why it is saying x coordinate. But this number is reached from the distance from the y axis. So I am saying x coordinate is what? The distance of the point from the y axis is the x coordinate. The distance of the point from the x-axis is called the y-coordinate. Okay, opposite. X-coordinate means distance from the y-axis. Y-coordinate means distance from the x-axis. Got my point? But see, this coordinate can be positive or negative. The coordinates can be, okay, distance is always positive, but coordinates can be positive or negative. Why both are, they can be positive or negative? The distance we are calculating the 4 units. No, it depends whether the coordinate is positive or negative depends on along which axis, whether positive x-axis or positive y-axis or negative x-axis or negative y-axis. We are calculating that distance. That depends. It is saying that the x-coordinate of a point is the perpendicular distance from y-axis measured along the x-axis. Okay, the distance from the y-axis is measured along the x-axis, but it is saying that again the coordinate is positive if distance is measured along the positive direction of x-axis and negative if negative elsewise. If I measure the distance along the positive direction of x-axis, the coordinate of x-coordinate is positive. If I measured it along negative x-axis, the coordinate x-coordinate is what? X-coordinate is negative. So we can say the x-coordinate of q will be negative since the distance from axis is measured along negative x-axis. The x-coordinate of p will be positive since it is measured along what? Positive direction of x-axis. Got my point? Same thing with y-coordinate. Same thing. Y-coordinate is what? Direction, the distance, perpendicular distance of the point from the x-axis, that is the y-coordinate. And we will see, and that is also called the ordinate. So I am writing here the y-coordinate of a point is its perpendicular distance from x-axis measured along the y-axis. Perpendicular distance of x-axis from x-axis measured along the y-axis, and is called the ordinate. Got my point? Then it is saying the coordinate is positive if distance is measured along the positive y direction. Here the distance was measured along the positive y direction, so the y-coordinate of p is positive. Here the distance was measured along the negative y direction. Okay, so here the y-coordinate will be negative. Okay, so what are the coordinates? Now we will find. See, I was telling that the distance from the y-axis is the coordinate. The distance of the y-axis of a point, the distance of a point from the y-axis is the x-coordinate. So here the x-coordinate is 4. Okay, here the x-coordinate is 4 since the distance is 4 units, and the y-coordinate is 3 since the distance is 3 units. But see whether it will be positive or whether it will be negative. We have to see along which direction it is. Along the positive x direction or y direction we are taking, or negative x y direction we are taking. From there we will calculate whether the coordinate will be positive or negative. We have written the coordinates 4 and 3. The coordinates distance was found using the positive x direction, so the x coordinate is positive. The distance was found using the positive y direction, so the y coordinate is positive. So it will remain as 4 and 3. But in this case, the second case of point Q, the distance from y-axis is 3 units. Distance from y-axis is called what? X-coordinate. So this is 3. Okay. And distance from x-axis is 2 units. So this is the ordinate. So ordinates are coming as 3 and 2. But here the distance is calculated from when measured along the negative x-axis and negative y-axis. Since this is negative x-axis, so if measured along the negative x-axis means the x-coordinate will become negative. If measured along the negative y-axis means the y-coordinate will become negative. So y-coordinate becomes negative since it is measured along the negative y-axis. So the coordinates will become -3 and -2 for the number point Q. Okay, so the same thing is written here. The x-coordinate of point P is what? 4. Point Q is -3. 4 -3 is the x-coordinate. For the y-coordinates of point P is 3 and point Q is -2. Okay, so the coordinates of point can be written as what? I wrote it in the previous slide. Coordinates are written as first x-coordinate, then comma y-coordinate it is written. So the coordinates of point P is x-coordinate is 4, y-coordinate is 3. So 4, 3, and the coordinates of point Q is -3 and -2. Okay, and one more thing is coordinates describe a point uniquely. Coordinates describe a point uniquely in a plane. If I specify coordinate 4, 3, 4, 3 is different from 3, 4. Is different from 3, 4. Okay. 4, 3. 4, 3 is not equals to 3, 4. Okay, those are two other points. This is 4, 3. 3, 4 is actually here. 3 is x coordinate, so distance from y axis 3 here I am taking. Then distance from x axis is 4, so this is 4 units. This is actually, this point is actually 3, 4. See, this is 3, 4, this is 4, 3. Okay, so both are different. No, this is 4, 3, this is 4, 3, this is 3, 4. So both are different numbers. So that is what it is saying, that coordinates describe a point uniquely in a plane. Okay, there are some other observations also. What are the observations? It is saying that every point on the x-axis has 0 distance from the x-axis. Hence, y coordinate of every point on x-axis is always 0. See, if I take a number, so this is suppose a point. This is another point Q. R I am taking. This is another point R. See, distance of this point R from x-axis is what? Distance of this point R from x-axis is 0, since it lies on the x-axis itself. Since it lies on the x-axis, so the distance from the x-axis is 0. If distance from the x-axis is 0, that means what? Y ordinate is the ordinate, not y coordinate, the ordinate I am telling. Suppose I am taking here, see, this is point R. Okay. For point R, the ordinate is equals to 0. Why it is 0? Since the distance from the x-axis is 0. Since the distance from the x-axis is 0, the ordinate is 0. But the abscissa, okay, the abscissa will not be 0. Abscissa will be what? The distance from the y-axis. The distance from the y-axis here is what? 0, 1, 2. From 0 it is 1, 2. So the distance from the y-axis is 2. So the abscissa will be 2. Okay. So coordinate will be written as 2, 0. The same thing it is written here. Every point on the x-axis has 0 distance from the x-axis. Hence y coordinate at every point on x-axis is always 0. Okay, y coordinate of every point on the x-axis, that is ordinate, is always 0 for the points lying in the x-axis. Okay, therefore any point x on the x-axis is represented as x, 0. If I write 2 is lying on the x-axis, so the coordinate of that point will be 2, 0. Similarly, suppose I take a point S. Suppose I take, this is the point S. Okay, this is point S. In point S, the abscissa is 0. The abscissa is 0. Why it is 0? See, the distance of this point from the y-axis is 0, since it lies in the y-axis itself. So distance from the y-axis is what? Abscissa or the x-coordinate. Distance from the y-axis is what? Abscissa or the x-coordinate we are saying. So x-coordinate is 0 here. But y-coordinate will be what? Distance from the x-axis. Distance from the x-axis is 1 unit. So the ordinate will be equals to 1. What will be the coordinate then? Coordinate is, first abscissa is 0, ordinate, then second is ordinate 1. So we will be writing 0, 1 as the ordinate for point S. Same thing it is written here. Similarly, every point on the y-axis has 0 distance from the y-axis. Point on the y-axis will have 0 distance from the y-axis. Hence, x-coordinate of every point on the y-axis is always 0. Always the x-coordinate for that point will be 0. Therefore, any point on the y-axis is represented as what? It is represented as 0, y. Okay, 0, y. The coordinates of origin are 0, 0. Why it is 0? See, this is the origin point. The distance from y-axis is 0. The distance from x-axis is also 0. That is why both the x-coordinate and y-coordinate are 0 here. So the coordinates of origin we are writing as 0, 0. Got my point? Now it is saying, another point it is saying, a point in first quadrant is of the form plus plus. What does it mean? What does this point mean? Okay, a point in the first quadrant is of the form plus plus. What does this mean? Plus plus means both the x coordinate x coordinate is positive, y coordinate is positive. Plus means both are, plus means positive. The location here is x coordinate is positive, y coordinate is positive. Here the x coordinate is negative, y coordinate is positive. What my point? That is actually I am writing here plus means x and y coordinates both are positive. Okay. Minus plus means x coordinate negative while y coordinate is positive. What my point? So it is saying that all the numbers, a point in the first quadrant is of the form positive. See, every point that lies in the first quadrant, this is the first quadrant I told you earlier, this is the first quadrant. Every point in the first quadrant will be measured along the positive x direction, will be measured along the positive y direction, y axis direction. Since it is measured along the positive x direction and y direction, I always told the plus or minus and based on which direction of x axis or y axis the distance is calculated. Okay, since both x and y directions are positive in this quadrant, so the first x coordinate and y coordinate will be positive. The x coordinate and y coordinate both will be positive. Okay, but in the second case, in the second quadrant, the x direction is negative. If the direction of x is negative means x coordinate is, if the direction x is negative, okay, x coordinate will become negative, but here y direction it is positive, so the y coordinate will be positive. Okay, similarly in the third quadrant the x is also negative, x direction is negative, y direction is negative, so both x and y coordinate will be negative. You can see this is -3 -2, x coordinate negative, y coordinate negative, minus. What happened? Here you are seeing plus 4, 3 both are positive. Okay, similarly in the fourth quadrant the x is positive, the y is negative. If x is positive means the x coordinate will be positive. If the y is negative means the y coordinate will be negative. Okay, so if the coordinate of a number, suppose I tell that in which quadrant the coordinates 4, 3 lie, in which quadrant the coordinates 4, 3 lie. From here you can say this is first quadrant. Why first quadrant? Why we are saying first quadrant? Since 4 and 3 both are positive coordinates. If both are positive coordinates, that is the first quadrant. Okay, if both are negative coordinates, it is the third quadrant. Okay, if the x coordinate is negative, and the y coordinate is positive, that is the second quadrant. If the x coordinate is positive, y coordinate is negative, that is the fourth quadrant. That is the thing that is written here. A point in first quadrant is of the form plus, a point on the second quadrant is the form minus, a point in the third quadrant is the form of the form minus, a point in the fourth quadrant is of the form plus, minus. Got my point? So this was the Cartesian system that is the portion in class 9th. So let us revise whatever all we have learned till now. Okay, the question was actually to find the location of points P and Q in the Cartesian plane. This was the point P, this was the point Q. To find that, what did we do? We put two perpendiculars to the y-axis and x-axis. Okay, we know we drew two perpendiculars to the y-axis and x-axis from each of the points. Okay, then what did we do? We found the distance. This is 1, 2, 3, 4 units distance from the y-axis. Then we found the distance from the x-axis. This is 1, 2, 3 units. So for point P, it is 4 units distance, at 4 units distance from y-axis and 3 units distance from x-axis. Similarly for point Q, it is 3 units distance from y-axis and 2 units distance from x-axis. Got my point? So find the distance of point P and Q from an x and y axis respectively. Okay, then we found the coordinates. What is those coordinates? If the distance from y axis is the x coordinate and distance from the x axis is the y coordinate. Okay, and a point is represented using what? First we write the x coordinate, then we write the y coordinate. Okay, for a point, we represent a point using what? X and y coordinates. First we write x coordinate, then we write y coordinate. And see, if distance from y axis is x coordinate, and the distance and the coordinate will be positive if it is measured along the positive direction axis. Okay, if it is measured along positive x axis, it is positive. If it is measured along positive y axis, the y coordinate will be positive. Okay, if it is measured along positive negative x axis, the x coordinate will be negative. If the distance is measured along negative y axis, the y coordinate will be negative. Okay, x coordinate is called abscissa, y coordinate is called ordinate. These things we have learned. Then we found the x coordinates. Since the distance is 4 and it is measured along the positive x axis, it is 4. The x coordinate is 4. Since the distance from the x axis is 3 units and it is measured along the positive y axis, the y coordinate is 3. Here the distance from the y axis is 3 units but measured along the negative x axis, so the x coordinate is -3. Here the distance from the x axis is 2 units but it is measured along the negative y axis, so the y coordinate is -2. Okay, and we saw that coordinates describe a point uniquely in a plane. Two coordinates are never equal, they are unique. Okay, if I say number A and number B have two same coordinates, that means the 2 points are located in the same point in the Cartesian system. Okay, then we saw that a number which exists in the x-axis will have its y ordinate as 0. Okay, y ordinate as 0, and number which exists in the y-axis will have its x ordinate as 0. Okay, and the coordinates of origin as 0, coordinates of origin are what? Coordinates of origin are 0, 0. Okay, and we saw that in the first quadrant the x coordinate and y coordinate both will be positive. In the second quadrant the x coordinate will be negative, y coordinate will be positive. In the third quadrant both the coordinates will be negative. In the fourth quadrant the x coordinate will be positive but the y coordinate will be negative. This is the property of quadrants. Okay, so next we will look into examples. So the first example, it is saying, see the figure to the left and complete the following sentences. It is saying abscissa. Abscissa is what? X coordinate. I have already told you. Ordinate is y coordinate. It is saying the abscissa and ordinate of point B are. This is point B. That is point B. We have to find the abscissa. What is the abscissa? Abscissa means x coordinate. X coordinate means distance from the y axis. Measured along what? Positive x axis here. It is measured along positive x axis. The distance it is coming as 1, 2, 3, 4. 4 units. The distance is 4 units. Okay. Since it is measured along the positive x axis, so the abscissa will be 4. Got my point? The abscissa will be what? The abscissa will be 4. Okay, now for the ordinate part we will measure the distance from the x axis. From the ordinate part we will measure the distance from the x axis. Okay, from the x axis the distance is, this is 1, 2, 3. 3 units is the distance. Since it is measured along the positive y axis, the ordinate will be 3. So the coordinates will come as what? First x coordinate is 4, y coordinate is 3. These are the coordinates of point B. Again it is saying find the coordinates of point M. Okay, distance from y axis is 1, 2, 3. Okay, 1, 2, 3. So distance is 3 units. Distance of y axis is 3 units, but it is measured along negative x axis. It is measured along negative x axis. So the x coordinate will be -3. Okay, the x axis will be -3. Now distance from the x axis of point M is 1, 2, 3, 4. That is, it is coming as 4 units. Distance is 4 units. Okay, since it is measured along the positive y direction, the y coordinate will be +4. So the coordinates are coming as x coordinate is -3, y coordinate is +4. Got my point? Then the x coordinate and y coordinate of L it is telling. What is L? This is the L, point L. So the x coordinate will be distance from the y axis. Distance is 1, 2, 3, 4, 5. This is 5 units is the distance. 5 units is the distance. Since it is measured along the negative x axis, So the x coordinate will be minus 5. Now it is saying that y coordinate from the x axis we have to find the distance for y coordinate. 1, 2, 3, 4. It is coming as 4 units. Since it is measured along the negative y axis, the y coordinate will be minus 4. Okay, the coordinate of L then can be x coordinate is minus 5, y coordinate is minus 4. Okay, then the x coordinate and y coordinate of point S. This is point S. Okay, x coordinate means distance from y axis. Distance is 1, 2, 3. So distance is coming as 3 units, and it is measured along what? Positive x axis. So the x coordinate will be plus 3. Then distance from the x axis is the y coordinate. This is 1, 2, 3, 4. So distance is coming as what? Distance is coming as 4 units. Okay, 4 units, and it is measured along negative y axis. So the x coordinate will be minus distance, that is minus 4. So the coordinates of S are what? 3 and minus 4 are the coordinates. Okay, next we move on to the second question. It is saying that write the coordinates of the points marked in the figure. Okay, so the first point is point A. Point A. Point A, it is in the x-axis. X-axis. So x-axis we know it is represented as x comma 0. What is x? X is the distance from origin. X is distance from origin. What is the distance? 0 to 1, 1, 2, 3, 4. So the distance is 4. So we are writing the coordinates as 4 comma 0. Again, this point is on the y-axis. Y-axis we know point B. Point B is on the y-axis. Y-axis we know. The reason we know it is coordinates 0 comma y. Okay. What y is what? Distance from again origin. Y is distance from origin. What is the distance? What is the distance? Distance from origin is 1, 2, 3. 3 is the distance. So the coordinates is coming as what? 0 comma 3. Now C. C is also on the x-axis. So it will be written as x comma 0. But here it will be minus x. Why? Since it is measured along the negative x-axis. That will be minus x here for C. Okay. The distance is 1, 2, 3, 4, 5. The distance is 5 units. So the coordinates will be minus 5 since it is measured along the negative y-axis, x-axis, sorry. Minus 5 comma 0. Similarly, point D, it is also in the y-axis. But so we will write it as what? X coordinate will be 0, y coordinate will be minus y again. Since the direction is minus y, in minus y direction we are calculating the distance. What is the distance? 1, 2, 3, 4. 4 is the distance. So the coordinate will be x coordinate 0, y coordinate minus 4. Okay. Next is point E. This is point E. Point E lies in the what? Point E lies in the x-axis. X-axis. This is represented as what? X comma 0 since it is in the positive direction. The distance is what? 2 by 3. So x will be what? X will be 2 by 3 comma 0. Y coordinate is 0. X coordinate is 2 by 3. So this is the end of the section Cartesian system, the second section of this chapter. In the third section we will see how to plot these points. Suppose we are given 4 comma 2, how we are going to plot these points 4 comma 2. In the next section we will look into it. Okay, so thank you for giving your time for watching this video. If you found any discrepancy or any errors, or if you didn't like the video, please comment about it so that I can improve what all sections, what all portions you didn't like. Okay, you comment about it. If you liked also, then also you please comment so that it can motivate me to make these videos. Okay, and if you like the video, please please subscribe to my channel since the subscriber count is very low. Okay, subscribe to the channel if you like this video, and till the next video, stay healthy, stay safe, and thank you for watching.